Hello AP Statistics students. In this video, we are going to calculate, display, and compare the marginal and conditional distributions of a categorical variable. Now, what does that mean? So say you took a big survey, you have all this data, you put this data into a table. What do you do with it? Well, a picture is always great, but what else can you do? There's a lot of data, there's a lot of information, there's a lot of analysis you can do with that data, and we're going to take a look at some of it. So here's our example, example number 5. A survey asking 4,826 19 to 25-year-olds asks, what are the chances you'll have an upper class income by age 30? So here are our responses. You can see they're summarized here in this table. We've got 1, 2, 3, 4, 5 categories for their opinions, almost no chance, all the way up to almost certain. And then they're also broken down by gender, female and male. So, and here's all the totals for those. And you'll notice we have some other totals on each of the sides and the bottom. So, we've got the total of the rows and the total of the columns. Now, with that information, we might be tempted to ask or answer a question like this. From this table, can you conclude that there is a significant difference in the responses between the two genders? Why or why not? So is there a difference between the males and the females? Seems like a legitimate question. And so you might go to the table and say, oh, this number is bigger than that one. That number is bigger than that one. That number is bigger than that one. And this number is a lot smaller than that one. There's a problem with that. The problem is we didn't ask the same number of males as females. So of course the numbers are going to be different. We asked more males, so maybe that's why these numbers are bigger. We just asked more males than females. So sadly, right now we can't make any sort of conclusion for this question. So the answer here is no, we cannot conclude anything about the difference between responses from male and female responders. All right, we don't know anything, or at least we can't conclude anything yet. So what can we do? There are 3 main types of proportions or percents that you can find. The marginal relative frequencies, the joint relative frequencies, and the conditional relative frequencies. There's 3 of them here. I know that looks complicated. Let's break it down so it doesn't seem so bad. All right, first, the term relative frequency. Don't let that throw you off. All that means is a percent. Okay? We can't use actual numbers of responders in this situation because we asked more males than females, so we have to go with percents. So marginal, of course, we're going to go to the margins. So let's write down exactly what this is. So a marginal relative frequency is the percent of individuals that have a value for one categorical variable. Okay, just one. So what would an example of that be? I could ask something like, what proportion of all responders said they had a 50-50 chance? So again, another word not to get too freaked out by is the word proportion. Again, that also just means some sort of percent. It doesn't have to be a percent. It could be just written as a decimal. Remember, a decimal and a percent are interchangeable just by moving the decimal over 2 places. So I'm just asking for what percent of all responders said they had a 50-50 chance. Well, that's going to be a fraction. On the top, we're going to have everybody that said they had a 50-50 chance. And on the bottom of the fraction, it's going to just be the total number of responders. So we just have to go to our table, find those two numbers, and plug it in. So I've got it over here. Let's see. 50-50 chance. We had a total of 1,416. 1,416. And the total of everybody is down here, 4,826. Hopefully there you can see why this is called a marginal relative frequency. We use numbers on the margins, the totals, to find this. So now we simply just have to plug that into a calculator and see what we get. So we got 1416 divided by 4,826. Hit enter, and we get 0.29. It's not rounding up, so we'll keep it at 0.29. Now we have a number. Whenever you have a number in statistics, you have to tell me what that number means in context of the problem. All right, so we have to write a sentence. So 29% of responders or individuals believe they have a 50-50 chance. Chance of what? This is where we add context. Chance of having, and I forgot it already. You're going to forget it at some point. So you go back up to the top of the problem and read. Chance of what? You'll have an upper class income by age 30. Of having an upper class income by age 30. That's what we call context. You have to give context to your answer when you tell me what your answer means. So those are the marginals. They come from the margins. All right, second one, joint relative frequency. Again, relative frequency means percent. Joint, in short, means and, two. We are looking at two together here. This is the percent of individuals that have specific values for both categorical variables. All right, this is where people are in both categories at the same time. All right, what does that sound like? It's a pretty simple question. What percent of individuals, are female and answered a good chance? Question mark. So I want to know both. How many are both female and answered a good chance? Again, it's a proportion, so we are looking at a fraction. The top of the fraction is both female and answered a good chance. Now, what's the total here out of that? All responders, all individuals are my total. So now that I have my fraction written out, I just have to go to the table and find those numbers. Let's bring this up back over here. What do we got here? So female, start here, and a good chance is right here. So 663 out of the total 4,826. You see here now we are not using the margins because we have to be part of both categories. So we figure out where they intersect. All right, again, we just got to plug that into the calculator and then write a sentence that gives me context. Interprets what your answer means in context. So pull up the calculator. 663 divided by 4,826. Enter. 0.13, let's say the 7 rounds the 3 up to a 4, so 0.14. So what does that answer mean? 14% of individuals are both female and say they have a good chance, now it's time for context, of having an upper class income by age 30. Yes, it keeps sounding redundant because the sentence is so similar, but context is always important. Okay, so that's the joint relative frequency. One more, the conditional relative frequency. So this one is the percent of individuals that have a specific value for one variable among those within one category of the other variable. Okay. Now, what would a question like that sound like? I could ask, what proportion of females answered a good chance? I'm hoping you see, I tried to make these last two a bit similar, but hopefully you see the difference here. Now my total has changed for this proportion. When I write the fraction, on the top, it's going to be very similar. It's going to be female and a good chance. But the bottom of the fraction is going to be different. The total is different because I'm not looking at all the individuals anymore. I just want to know what proportion of females answered this, not the total survey group. So my total is just going to be the total females. That's the big difference here. So when I come over here to get my numbers from the table, females and a good chance is still 663. But now I'm not looking at this big total down here. I'm looking at just the total of females right there, 2,367. So that's what I'm going to use to get my answer when I plug in the calculator. Give myself a little bit more room here. Let's pull up the calculator. 663 divided by 2367 is 0.28. So again, context is everything. So 28% of, so here I'm not going to say all the individuals, just 28% of females said they had a good chance of having a upper class income by age 30. All right. Slight difference there with the conditional relative frequency. That bottom number in your fraction changes because you have a different total. You're not looking at the entire group. You're only looking at one category as your total. All right. What I'd like you to try to do now is answer each one of these questions using the table. Some of them are marginal distribution, some of them are joint, some of them are conditional. See if you can identify what they are and then actually find that percent and write a sentence for what it means. So pause the video and try those out. Good luck.